the cosine rule. Again, I'm going to drop in that perpendicular. Now, x there in the right-hand side triangle, I could say, well, that's going to be b squared minus x squared, Pythagoras' theorem. I could look in the other triangle, so I'm now looking on the left-hand side, also with Pythagoras' theorem, and we get c squared is h squared plus a minus x all squared. All right, well, it's the same h squared, so let's sub in b squared minus x squared for h squared. And so we now have b squared minus x squared plus a squared minus 2ax plus x squared. All right, that gives me b squared plus a squared minus 2ax. But looking at that right-hand triangle, I could say x over b is the cosine of c. So subbing that in, and we see our, well, cosine rule. Cosine rule, basically Pythagoras' theorem. We don't see that in Pythagoras' theorem because, of course, the angle would be 90 degrees and the cosine of 90 is 0. So you just get c squared equals a squared plus b squared. All right, so a squared is b squared plus c squared minus 2bc cos a, or it might be b squared is a squared plus c squared minus 2ac cos b, or it might be c squared is equal to a squared plus b squared minus 2ab cos c. Again, it's that situation where we have two sides and the included angle. We want to find t. So for our one, it would be f squared plus m squared minus 2fm cos t. Subbing in. Thing to be careful with in your calculations, remember to find the square root. It's a very common mistake where people work out t squared and they just write that down for the answer. So you've got to find the square root. In this case, I've done it to the nearest whole number, 8 units. Here we go. How do we find the angle? Well, some people like to remember the formula to find the angle. Some people just say, I'm just going to remember the cosine rule and then rearrange it. Whatever your preference is. There's our cosine rule for this one. Rearrange it, make cos f the subject, and we get a squared plus s squared minus f squared on 2as. Substitute in, here's an interesting thing, 6 squared plus 15 squared minus 20 squared. Positive or negative? 6 squared plus 15 squared minus 20 squared. Now, I think it turns out to be a negative number. And this is where the cosine rule is a little bit superior to the sine rule because it will find the obtuse angle. And yes, indeed, it turns out to be 140 degrees, 33 minutes. Now, what about this one? We want to use the sine rule, but I can't because I don't have the conditions for the sine rule. I've only got one angle. Cosine rule, oh geez, I don't have the included angle. We can still use the cosine rule, however. Let's set it up. I've gone with a squared. See, angle A is the one I know. So I set it up as if I'm finding side A. So a squared is b squared plus c squared minus 2bc cos a. Substitute in. Now, what we've got is a quadratic equation. Let's make it look like one. There it is. b squared minus 14b cos 25 plus 40. Put it into the quadratic formula. Because I wouldn't expect you to be able to work out what multiplies together to give 40, adds together to give minus 14 cos 25. That's a little bit hard to work out. So here's our calculation to do. We get two possibilities. Now, depending on the information we've got, whether we can narrow it down. Now, in this case, I can't narrow it down. So I'm saying, well, these are my two possibilities. It might be 5.85, but it might be 6.85. Let's do a 3D trig question. Comes from the 2003 HSC. It's a lovely story. Follow along. David's in a life raft. Anna is in a cabin cruiser searching for him. Where are you? Okay. They're in contact by mobile phone. David tells Anna, who amazingly has changed the way she spells her name, that he can see Mount Hope from David's position. Now, he also happened to have with him, in his little life raft, he happens to have a theodolite. That's one of those things surveyors use to measure angles and things like that. And so he goes, oh, look, yeah, I can see Mount Hope. It's angle of elevation 16 degrees. But then he pulls out his compass and goes, oh, and the bearing's 109. Well, lucky for David, Anna, who's on the cabin cruise, goes, well, I've got a theodolite as well. So I'll have a look at Mount Hope. Oh, it's got an angle of elevation of 23 degrees, and I'll pull out my compass. Oh, the bearing's 139. I love maths in the real world. It's fantastic. Now, they also happen to know that Mount Hope is 1,500 metres above sea level. So now, and it goes fantastic, I can go and find David. I just got to work out the distance and the bearing I'm going to travel on to find him and rescue him, and he can come aboard the cabin cruiser. All right, here's the diagram. Let's draw some triangles to make life easier for ourselves. So there's angle HDB and angle HAB, and I'll put the bearing down. There's David, 109 degrees to Mount Hope, and Anna's over there, bearing 139 degrees to Mount Hope, and we'll join that up. That's the distance we want to find, and there's our bearing that we want to find. They're the two pieces of information we want. Okay, what sides do we know at the bottom? None at the moment. But I can work out BD. BD over 1500 is tan 74, so BD is 1500 tan 74. Similarly, in the other triangle, I would end up with 1500 tan 67. And by the way, if you're in the exam, yes, you can just do that. You don't have to do all the working out again. They're just two different triangles with exactly the same situation. So logic works out what the answer should be. Let's put that on our diagram. We now have two sides. If I've got an angle, I could use a cosine rule. Can we work out an angle from the information we've been given? There's a compass there. Bit of geometry, we're going to work this thing out. So angle NDB plus angle DBN double dash, I've called it, they're going to add up to 180. We've got co-interior angles. So I can work out the angle DBN double dash is 71 degrees. I could do a similar one and come up with ABN double dash. That'll be 41 degrees. Well, ABD will be the difference of the two. So ABD is 30 degrees. We now have an angle. I think we've got all we need for a cosine rule, haven't we? So B squared is equal to this wonderful expression right here. 1500 squared tan squared 67 plus 1500 squared tan squared 74 minus 2 times 1500 tan 67 times 1500 tan 74 cos 30. 2,799 metres. You're talking 2.8 kilometres. No wonder she couldn't see him. Long way away. That's how far apart they are. Let's find the bearing. What do we know? We know that angle's 139. If I could find angle DAB, add it onto that, we're going to have our bearing. Okay, I'll use the sine rule for that one. The sine of DAB over 1500 tan 74 is sine 30 over B. I haven't written 2,799, you'll notice, because remember, that's an approximation. I'm going to use the exact value that we found, which is still in my calculator, so I'll use that one. Make sine DAB the subject. We get two possibilities. Which one makes sense? Is it going to be 69 degrees 9, or is it going to be 110 degrees 51? If it is 69 degrees 9, then angle BDA would be 80 degrees 51. But, because of the length of the sides and all that, I know angle DAB has to be bigger than BDA. So that's not possible. So it has to be the obtuse angle in this case, 110.51. By the way, remember, this was an HSC question. That was a mean little twist they put at the end. After all that working out, people would have just gone, oh yeah, 69 degrees 9, away we go. So okay, we now know that is 110.51, therefore the bearing is 249.51. 6J, 6K,